Hello, today we're starting Unit F. We're actually on our second unit because we did one yesterday in class. This is lesson 5.2 talking about polynomial functions. A polynomial function is in the form f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 and so on. Where a sub n does not equal 0, the exponents are all whole numbers and the coefficients are all real numbers. This is going to become important because in the beginning we're going to recognize whether we have a polynomial function or not. The leading coefficient is the coefficient in the term of a polynomial function that has the greatest exponent. So we're going to look at the term that has the greatest exponent and look at what that coefficient is. The degree is the exponent in the term of a polynomial function where the variable is raised to the greatest power. We're going to talk about this as well. And the constant term is a term that has the number part but no variable part. We have some names that you do need to recognize. Oh, and standard form of a polynomial, we've already talked about this, is when it is written in with its terms in descending order of exponents from left to right. Now, if there is a degree of 0, that means there's no variable in it. We call that constant. If there is a degree of 1, like y equals mx plus b, like y equals 3x minus 5, that's a linear. If there's a degree of 2, that's a quadratic, and you know that because we've done 2 whole units of quadratics. If there's a degree of 3, it's a cubic, and if there's a degree of 4, it's called a quartic. Okay, so we're just going to get started with some examples. It says tell whether the function is a polynomial function. If it is, write it in standard form and give the degree, type, and lead coefficient. So off to the side, we'll write the degree, the type is the name, and lead coefficient. Okay? Okay, let's get started with the first one. The first one, I want you to look at this. We have exponent of a half and we have exponent of 1. Now a half, another way to write that is the square root of x. So because of this, this is actually not a polynomial. The exponent is not a whole number. Okay, this one, let's write it in descending order. Looks like it's a polynomial function. So we would write it as negative 8x to the 4th plus 20x cubed plus 10x squared plus 18. So when I look at this, the degree is 4 because that's the highest exponent. The type, since it's a degree of 4, we call it a quartic. That's above in the chart. And the lead coefficient is negative 8. Now let's look at this problem. Look at what this exponent is. This exponent is a variable, so it's not a polynomial function. Now I'm trying something a little bit different this semester. Instead of doing a summary at the end, because I was noticing people weren't writing that down, we're going to do you-try problems. I'm not going to go over this until tomorrow in class, but I do expect for full points that you have these you-tries complete. So go ahead and pause the video and try these 2 problems. You're doing the same directions as I did above. Tell whether it's a polynomial function and give the degree, type, and lead coefficient. Okay, moving on, we're going to talk about evaluating functions. I believe everybody already knows how to do this. What we need to be careful of is your calculators. Use parentheses, especially if you're substituting in a negative number. So all I'm going to do is plug in 3. If you want to type this in on your calculator, you can. Be very, very careful when doing that. Lots of mistakes happen on the calculator, and this is not a difficult problem because this is just substitution. So make sure you try this along with me, and you should get 23 as your answer. So that's called evaluating it by direct substitution. Again, you can go ahead and pause the video and try number 1. Okay, now we're going to do something called synthetic substitution. This is another way to evaluate a polynomial function. Now I'm teaching this because of course you can just do direct substitution, but we're going to use synthetic substitution when we do polynomial division. So this is just warming us up to get to that point. I have the directions written out. Some people like to see the steps when they're doing a problem and some don't. Now, I'm going to start with number 2. I actually meant to make this number 1 because if you look at number 2, it's exactly like this example that we tried. And I want to show you that doing it this way, we get the same answer. Okay, so the first thing we're going to do is we're going to write what we're substituting in on the outside. We're going to make kind of a partial box here. We're going to list all the coefficients of the polynomial function in descending order. If anything is missing, you put a 0 as its placeholder. So I have to the 4th, I have to the 3rd, I'm missing a squared, I have an x, and I have a constant. So what we do is we drop this down. That's 2. Oh, it's hard to see. Let me move this. Okay. We drop this down. We do multiplication. 3 times 2 is 6. We write it in the next column, and then we add. -5 plus 6 is 1. Now we do multiplication. 3 times 1 is 3. Now we add. Now multiplication again. 3 times 3 is 9. Now we add. Multiplication again. 3 times 5 is 15. Now we add. This is our final answer. And we did get what we got above using direct substitution. Okay, let's go ahead and try this problem. You see the steps there. I'm just going to scroll up a little bit so I have more room to write. So we're going to write what we're substituting in on the outside. Go ahead and list our coefficients. Just because I don't have a fourth doesn't mean I have to do a placeholder there. Just start with your highest exponent. And then go ahead. You have a cubed, you have a squared, you have an x, and you have a constant. So we don't need a placeholder. Drop the first term down. Now we start with multiplication. 3 times 5, then we add. 3 times 13, then we add. 3 times 31, then we add. 109 is our answer. So technically the way to write this would be f of 3. When we evaluated this function at 3, we got 109. Okay, again, I have another you try. Go ahead and pause the video and try this you try on your own. I expect to see it complete tomorrow in class. Now, basically what we're doing is you need to understand polynomial functions. How do we recognize a polynomial function? What's the degree, the type, the lead coefficient, how to use direct substitution and synthetic substitution. Any questions, comments, or concerns, go ahead and write it on the bottom of your paper, and I'll see you tomorrow in class.